So now we look at example 1. Consider the function fx is equals to x squared, x plus 3 times x plus 3. Find, let's say A, the x-intercept and y-intercept. B, the interval where the function is increasing or decreasing, hence determine the extremum point. C, the interval where the function is concave up or concave down, hence determine the inflection point, if any. Finally, we will sketch the graph of fx. Let's say we look at A. So in order to find the x-intercept and y-intercept, let's say x-intercept. For x-intercept, y is equals to 0. So in this function, y is referred as fx. So it means that 0 is equals to x squared times x plus 3. So next is x squared is equals to 0 or x plus 3 is equals to 0. So x is equals to 0 or x is equals to negative 3. Next, we try to find the y-intercept. For y-intercept, x is equals to 0. So in this case, fx is equals to 0 squared times 0 plus 3. Any value multiplied by 0 is 0. So this is A, x-intercept and y-intercept. Now we move on to question B. So if you still remember the step, in our first step, we need to find the f prime x. So before we find the f prime x, first I try to expand the function x squared times x squared times 3. So we have x cubed plus 3x squared. So first I try to differentiate f prime x. I should have 3x squared plus 6x. In our second step, we will let f prime x is equals to 0 in order to find the value of x. So here we have 3x squared plus 6x is equals to 0. So from here, I can factorize, or I can try to simplify by divide by 3. So I have x squared plus 2x is equals to 0. I try to factorize x plus 2. So I will have x is equals to 0 or x is equals to negative 2. So next, in the second step, we will try to find the critical point by substitute x into fx. So when x is equals to 0, remember, we need to substitute into fx. So fx is equals to 0 power of 3 plus 3 times 0 squared. So here is 0. So the first critical point is 0 and 0. Next, when x is equals to negative 2, our fx is equals to negative 2 power of 3 plus 3 times negative 2 squared. So here I should have negative 8 plus 3 positive 4, 12. So here is 4. So our next critical point is negative 2 and 4. So this is the second step. In our third step, we will draw the critical line. Since we have two critical values, one is negative 2, another value is 0. So means that we need 3 intervals, where the first interval is from negative infinity until negative 2, second interval negative 2 to 0, third interval 0 until positive infinity. So next, we will draw the table in our fourth step. So let's say I try to insert the table. I need 3 intervals, 4 rows. So here is our interval. So for the first, so this will be interval. This will be our, let's say, this will be our interval. So here is test value, and here is sign of f prime x, where our f prime x is, let's say our f prime x, where is f prime x? So this is our f prime x, 3x squared plus 6x. So is 3x squared plus 6x. So the first interval is from negative infinity until negative 2. So the first interval. So next, let's say we look at the first interval. Let's say the first interval is from negative infinity. Okay. Let's say I have to change to this one. Let's say the first interval. So the first interval is from negative infinity. Let's say symbol of infinity. Negative infinity until negative 2. So the second interval is from negative 2, let's say negative 2 until 0. And the third interval is 0 until infinity. So the test value, next the test value must come from the interval. Let's say from negative 2 until negative infinity. Let's say I choose negative 5. And then negative 2 until 0. Let's say I choose negative 1. Finally, from 0 to positive infinity, let's say I say 5. Next, we will substitute into x. Let's say 3x squared plus 6x. So if I try to substitute negative 5, so what I should have here is 45, which is a positive symbol. If I substitute negative 1 into x, so into f prime x, so I should have negative 3, which is a negative symbol. So we just take the symbol, let's say. Finally, if I substitute 5 into f prime x, I should have, let's say, positive 5. I have 105, which is positive. So next, the question is, find the interval where the function is increasing or decreasing. So, increasing, we will choose the positive sign. So, increasing, let's say, increasing interval, we will choose the positive sign, which is negative infinity until negative 2 or 0 until infinity. For decreasing interval, so we will choose the negative sign, which is from negative 2 until 0. So next step, so this actually is step increasing and decreasing, is step 5. So this is step 5. So step 6, determine the extremum point. Now we have two values. One is negative 2, another value is 0. So for negative infinity until negative 2, the graph is, you can see that is increasing, positive. So the graph will be increasing. And then from negative 2 to 0 is decreasing. So this is a maximum point. So negative 2 is a maximum point. And then from here, let's say 0 is here. From negative 2 to 0, the interval, the graph is increasing, decreasing. And finally, from 0 to infinity, increasing. So 0 is a minimum point. So negative 2 is a maximum point. So I can make a conclusion here. Maximum point is equals to, we can refer to our critical point, negative 2 and 4. So maximum point is negative 2 and 4. Minimum point is equals to, so let's say we look for the minimum point, if 0, 0 and 0. So the minimum point is 0 and 0. So in step number 7, next we look at step number 7. We will try to find the second derivative. So our first derivative, let's say, I try to rewrite our first derivative is 3x squared plus 6x, 3x squared plus 6x. So our first derivative is 3x squared plus 6x. In the step 7, the 7th step, we will find the second derivative. So it will be equals to 6x plus 6. So step 8, let the second derivative equals to 0. So means that 6x plus 6 is equals to 0. 6x is equals to negative 6. X is equals to negative 1. So this is the inflection value. Step 9, we will draw the inflection line. So under the inflection line, we have one value which is negative 1. So we need two intervals. So next step, step number 10. So we will try to draw the table, let's say. Try to draw it manually. Okay. First is interval. Next is test value. So this is sign of our second derivative is equals to 6x plus 6. So the first interval is from negative infinity until, so the inflection one is negative 1. So negative infinity until negative 1. The second interval is negative 1 to positive infinity. So our test value, let's say here is negative 5. Here I put 0, for example. So against the test value must come from the interval. So negative 5, 6 times negative 5, negative 30. So here is negative. If I put 0, here is positive. So again, if you still remember, so this is our second derivative. If the sign is positive, refer to concave up. If the sign is negative, concave down. So first is negative. So concave down. We will choose the negative sign, which is from negative infinity until negative 1. And concave up, we will choose the positive sign, which is from negative 1 until positive infinity. So since this one, I can try to find the inflection point. So when x is equals to negative 1, remember, substitute into fx, not f prime x or second derivative. Substitute in fx. So here, again, my fx is, this is our fx, x cubed plus 3x squared. So x cubed plus 3x squared. So when x is equals to negative 1, so here is negative 1 power of 3 plus 3 times negative 1 squared. So here is negative 1 plus 3 times 1. So 3 minus 1 is positive 2. So our inflection point will be equals to negative 1 and 2. So finally, so this is P, actually this is C. So this is for C. And then if you look at D, using the above information, sketch the graph. Okay, finally, question D, we will try to sketch the graph. So let's say we have y-axis, and then we have x-axis. First, we look at the intersection. So the intersection is 0 and negative 3 and 0. So 0 and negative 3. So let's say here is 0. Here let's say negative 1, negative 2, negative 3. Here is negative 3. So we have two intersection points. First is here. Another point is here. Next, we will look for the maximum point. So the maximum point will be at negative 2 and 4. Minimum point is 0 and 0. So negative 2 and 4, 0 and 0. So negative 2. So next we will look for the maximum point. So here is negative 2, let's say. Here is negative 1. Here is negative 2. So negative 2 and 4 is around here. So this is our maximum point, which is negative 2 and 4. And our minimum point is here, 0 and 0. So we can start to sketch the graph. So since this is a maximum point, so our graph will look like this. Next, since 0 and 0 is the origin is the minimum point. So suppose that after this point, our graph will move upward. So this is our graph. Maximum point. Here is our minimum point. And then our inflection point is negative 1 and 2. So negative 1 and 2 is around here. So here is our inflection point. Negative 1 and 2. So maximum point, minimum point, and the inflection point. So here is negative 1. So this is our negative 2. So this is our graph.